Okay, we've started the recording. Welcome back, everyone, to the last day of the first week of Web Fundamentals. You guys have made it this far. I'm proud of you guys. So let's go ahead and take a look at our calendar really quickly here. We're going to go over a morning algorithm as usual. Then we have a JavaScript activity. And then at 2, we have a trivia party. So in the afternoon, it gets light. Today we're have some assignments called loop challenges and FizzBuzz. These are more JavaScript oriented challenges. Most of you should be able to complete these given the test for programming basics. And then homework is going to be click event and what is this, the hover event. So let's go ahead and get into today's lesson. So we are going to learn how to swap the values of variables and how that comes into play when we are writing functions. Okay. So, oh yeah, Leo's background is interesting. It's like he's like James in the Giant Peach or something.
Or The Hobbit, maybe a Hobbit home.
Oh, the Hobbit, yeah. All right. So we have fruit1 equals apples. And what type of variable is fruit1? A string, right? Fruit2 is also a string, therefore, because it's in quotations. So if we say fruit2 equals fruit1, let's T-diagram this now, just so we're clear. So we have variables, values, fruit, one is apples, fruit 2 is oranges. So if we now say fruit2 to equal fruit1, we are making fruit2 to equal apples. So if we console log this, what should our result be? Let's get some responses from the class.
Apples and apples.
There we go. All right. We can move on now. Okay. Now we have something a bit more interesting. We have ooh, what am I doing? This should be variable. This should be value. So if we say fruit1 is apples, and fruit2 is oranges. Now we have a new temp variable as well. So let's go ahead and introduce this temp variable. I'll say here temp. And temp is going to equal fruit1. So what is fruit1 right now? It's apples. And then we say fruit1 equals fruit2. So fruit2 says oranges. So then fruit1's new value becomes oranges. And then fruit2 equals temp. Temp right now is apples. So fruit2 becomes apples. So when we console log this, write the console up here. Our result should be what? Fruit2 and fruit1. Fruit2 is apples, fruit2 is oranges. So apples and oranges. I think I like the blue color better. Okay. So do we understand how that temp value works, how it comes into play? Imagine you have a cup full of apple juice and you have a second cup full of oranges. And you want to exchange the fluids. You want to put the orange juice in the apple juice cup, and you want to put the apple juice cup in the orange juice cup. Well, in order to do this, you're going to need a third cup to empty the apple juice into. Once you do that, then the apple juice cup should be empty. The original apple juice cup, fruit1. Now that it's empty, you can pour into it the orange juice. And now the orange juice cup should be available. So what you do then is you say that temporary cup, that third cup we've introduced that we poured apple juice into, pour that into the orange juice cup. And that's what this is doing. So it's just exchanging containers. You introduce a third container to put the contents in, you save that in so that you can do an exchange. Okay, let's get a pulse check from 1 to 10, how we're understanding the temp variable and how we can use that to swap values of variables. Okay.
How do you do it without a temp?
Without a temp in JavaScript, I don't want to show you guys that yet. There is a way to do that. In Python, all you have to do is say fruit1 equals fruit2 and fruit2 equals fruit1. It somehow knows. It's built into the language. Get this way down, and then later on in the JavaScript stack, you'll learn how to deconstruct, and that's a way you can do it so that you can do it without a temp value. But for now, a temp value is all you need. So sorry, it's like a non-answer, but there is a way to do it. I just don't want to throw in too much information right now. Okay, now while loops. What do while loops do? They're kind of like for loops, and they're kind of like if statements. So let's take a look here. Var start equals 0. So let's T-diagram this. Oh, I said I didn't like red. Okay. So we have start and it's equal to 0. We have end, we have end, and that's equal to 12. And then we say here, while start is less than end. So while loop, it checks here in the parameters to see if something is true. And if it is true, then do everything inside the function area. Here and here. Do everything in here if this is true. Excuse you, whoever that was.
Excuse me, I didn't mute my mic.
Nice.
I'm kidding. I thought you had that on purpose. So we have this if statement. If this is true,
Is the while statement continuous?
yes, if this is true, then we do everything in here. Okay.
Yeah.
So right now, start is at 0 and end is 12. So is this true? Yes, because 0 is less than 12. So then we do everything in here. We console log start, the string start plus end plus the value of end. So our console will look something like this. Maybe if I write the console down here. Okay, start 0 and it's 12. And then we decrease start by 2. So start plus equals 2. So then we have a new value here, 2. And then end minus equals 2. So then this becomes 10. And then we exit this while loop. And then it checks it again. While start is less than end. Is start still less than end? Yes. So we do this new console log. Start is 2, end is 10, and so on and so forth until start is no longer less than end. Then once this is no longer true, we exit this while loop and no longer enter it again. Okay, so it's like a for loop in that when we have that middle section of the for loop where it says if I is less than x dot length or whatever we say it's less than, it's going to run, but it's also like an if statement because it's checking if this is true, checking these parameters. So it has a bit of both in there. Okay, so I want you guys to still work on this one when we break out into groups. Let's work on this while loop. Let's console log it so that we know we understand it. And not console log it, T-diagram it. I wanted to make sure you guys know how to work with the while loop. So T-diagram this first, then move on to this function here. This function, we're going to reverse an array, like the reverse Uno card. So if we're given an array A, B, C, D, E, we want to return E, D, C, B, A. Return the same array, but in reverse order now. So how can we write a function that takes in an array, reads this array backwards? Well, there's the hint. And then returns that array's value. the reversed array. Okay, so I don't think this is going to be too difficult for you guys. But this should keep you busy here for at least 15 minutes. This one here, actually, sorry, excuse me. We already went over that. T-diagram this while loop, and then come up with this function and T-diagram it as well. No built-in functions because that's too easy. The built-in function, there's some inbuilt functions in JavaScript that will help you do this, but we want you to know how those inbuilt functions work. Okay, they're like already working machine parts. We want you to build everything from scratch so that you know how those inbuilt functions work. Okay? All right, any questions? All right. Let's go ahead and break out into rooms. If there's any group that I see that has one person, I'll move them around. So don't panic if you're alone in a room. Okay, I'll go ahead and start it now. Oh. Narciso, I accidentally included you somehow into this. Oh, I didn't click the start button. We're just staring at each other awkwardly. Okay, here we go. So now we have a temp value. We're holding the value at I. So R at I is initially A. So we have a temp value holding A. And then go ahead, continue.
Yes, so we can do this one, like we can follow along, we can do this here, and we can swap. So temp has now E, and A become, temp now has A. So anyway, you get the idea. To save time, let me just maybe speed up and go through instead of doing the swap. So we put A into temp, and A now array of I is now empty. So into array of I put array of J. Now array of J is empty. So put whatever I put in temp to J, which is A. So now they just swapped each other. So I plus plus, that means I becomes 1. And J minus minus just means J becomes 3. So it just go to the loop inside the loop again, and it tests this condition array.length /2. That means again it's less than I is less than still with 2. I think 3. 1 is less than 3. So it does again the swap, and I now is 2. And again 2 is less than it does this one. So
okay, so we have the swap. Now we say var temp equals R at I. I is now equal to 1. So that's going to be originally our B value. And then we say R at I equals R at J. And we know J is going to equal R dot length minus 1. And now that's going to be, what is it? 3? Where are we with J? Yeah, 3.
Yeah.
So then now R at I equals J. So that's how we do the swap. And R at J equals temp. So now the last value there at 3 is going to equal So B is equal to D now, and D is equal to B. So we've just swapped that. We're right before the point we need to reach the end. And then we increase I again, and we increase J.
Yes. So I becomes 3, now J becomes 2. So since the condition is not true, it's stopped. So it prints this one.
So now it's
Condition.
reversed.
I just created a variable here to hold the output, and that's the result.
Okay.
So I can run it for you. So A, B, C, D, E. It's reversed.
Okay, good job. You did this with the while loop and a temp value. So very good job, guys.
Me and
Um,
Carlos did ours a little bit differently.
Okay.
Basically the same thing, except we used a for loop for it.
Okay, let's see your group present.
So like I said, it's essentially the same thing. Except we put the values of I inside the for loop rather than down here for a while loop. And this one runs through it forward rather than backwards
Okay.
and sets the temp to the indice that I is at within the loop.
Okay.
And then sets I after to be the array length -1, so the last indice minus whatever value I is at currently, which will decrement through the loop, and then sets that value to temp,
Okay. Let's T
and then
diagram this.
returns.
Would you move the notepad? I'm gonna try to T diagram this here for the
Sure.
class. So let's make this here. And then here. Okay, so let's go through our variables. We have I, we have that to equal 0. And then what's r dot length -2? So what's r dot length?
R dot length originally is 5.
Dot length is 5. So divided by 2 is 3.5. And then you applied math dot floor, so then that would be 3.
Well, 2.5, right? I don't see you drawing on the screen at
Oh.
all.
You don't?
No, just the T.
Oh. Oh, okay. Excuse me. Okay. I guess I can only draw with the notepad on my screen here. Okay. So now it won't let me draw at all here. All right, let me see here.
I might be able to draw for you.
Oh, they'll take it away. So
No, go ahead. Yeah, I'll just draw for you.
yeah, thank you. All right, so let's create the var and value. So we have I equaling 0. Yeah, I did the division wrong. And then we say r dot length, which is 5 divided by 2. We floor that, and that's going to be
2.
2. So we're trying to get to I to get to 2. Once we've done that, we exit the for loop. Now we have the value temp. And temp equals r at I. I is at 0. So temp is going to equal A. And then we say r at I. So maybe can we make that a new value? R at I equals R at R dot length which we said it was 5, minus 1, which is 4, minus I, what's 4 minus 0? It's 0.
4.
So, oh, 4 minus 0 is 4. So let's enter 4. Excuse me. Thank you. Okay. Is that a 4 in our CISO?
So our temp is, so we have R of I minus, wait a minute.
Maybe let's make that a whole value. R dot length minus 1 minus I on the T diagram.
Uh, And we
Okay.
have R of I. So R of I we made equal to array at array dot length minus 1 minus I, which is E.
And the one below it would be 4, I think is what Josh is wanting. So ARR of ARR length minus 1 minus I would be 4.
Well, that's the value, right? That's the value, not
Right. So we're looking for the value at that number.
Mhm.
The number is 4, but the value is E.
Mhm.
So I got confused for a second there as well. Okay. So then now we say R at R dot length minus 1 minus I, which we said was the array value at 4, equals temp.
oops.
So temp right now is A.
Yep.
So now we've just swapped E and A. Okay, then we go through the for loop again because I is we increase I. So I goes to 1 now.
Oops.
Okay, now we say, well, I is less than 2, right? Because that's math.floor R dot length minus 2. So while 1 is less than 2, it is. So then we do this swap again. Temp equals R at I. And now I is 1. So temp equals that value at 1, which is B. Then R I equals R at R dot length minus 1 minus I. So R dot length is 5 minus 1 is 4 minus 1 again is 3. So what's R at 3 in this array? It's D, right? So then we say R at I equals D. And then R at R dot length minus 1 minus I equals temp. So that value that was D is now going to be B because temp is B. And then we increase I again. And now, is 2 less than math.floor at R.length divided by 2? No, 2 is equal to 2. So we exit this for loop. And if we return our array, it should read backwards now.
Yeah, Narciso helped us with the math floor there, and he explained it as it won't output anything different without it, but it runs the loop one more time because 2 as I becomes 2, it's still less than 2.5. And
Mhm.
so it swaps the value C in the array with itself.
Okay. Okay. Yeah, it's a good trick there as well. So C gets swapped with itself because they're going to be at the same place, R at I, and then R at I dot length minus I minus.
And that happens because this array has an odd number of values. So
Yes.
this will work with odd and even arrays.
Yep. Okay. This now the algorithms are getting a little bit more complex. So, but as we learn how to solve them, we're going to be learning how to solve even harder ones. Okay. So here we used a for loop. When we used a while loop, we didn't have to use r dot length minus 1 minus I. We just swapped the values. We just decreased and increased variables that held that end and beginning place of the array. And there's another simple way to do it, but it takes more memory. You can create a new array, a variable that holds a new empty array, and you can read it in reverse, and you add to that array as you read it in reverse.
That's what we did originally. We had it run through backwards and just push those values into a new array.
Right. And what's the issue with that?
It doesn't change the value of the original variable of the array. It creates an entirely new one.
Right. But what if you just say the original value just equals the new value? You can just swap them there. What's the issue still? Can anyone guess? I already told one group. Imagine this array. Yeah, imagine this array is billions of positions long, right? It's like it has billions of values. Then you have to create a whole new array to just read that initial array backwards, and then you're making a piece of data hold billions of more values. And so you're using a lot of data in that sense. So as we go through algorithms, we're not going to touch on the subject particularly here during web fundamentals as much as you will during the JavaScript stack with MERN. But you're going to want to optimize your functions for speed, for optimal speed and optimal memory. Okay, so we're just learning how to do this. So if you figured it out with just using a temporary value where you just read it backwards and then give the array the value of that temporary hold of reading it backwards, and that's fine. But as we go through this, let's make use of all the tools that we have. Now we know how to swap, and now we know how to use a while loop. So you know, the more tools you use, the more optimal you can make your functions. Okay, so that should end today's algo. We're already going half an hour over time allotted. Does anyone have any questions? Okay, no questions. All right, then let's go ahead and take a 10-minute break and get ready for our next session. Actually, let's make it a 15-minute break. You guys deserve a bigger break today.